Hi, hello dear students. Today I am going to start new chapter, that is motion in a plane. Chapter number 4, motion in a plane. In kinematics there are two chapters. One is motion in a straight line and motion in a plane. This one is the chapter number 4, motion in a plane. Okay, total 10 marks. Then introduction. What is the meaning of motion in a plane? Already I explained that one. Definition of a motion. What is the definition of motion, students? Motion nothing but body changes the position from one point to another point. Body changes the position from one point to another point is called as motion. For example, this one is an object or body or particle. When you apply certain amount of force on this body changes the position from one place to another place. That is called as motion. Here, motion in a plane. It is also called as two-dimensional motion. Two-dimensional motion. Motion in two dimension. Give an example for motion in two dimension. Motion in two dimension example kodri nodana. Example for that one, projectile body or circular body. For example, when you throw the shot put, okay, you gundestonu hogidaga, okay, shot put, that forms a projectile motion. That forms a projectile motion. Okay, when you throw the shot put, that shot put move in a space in the form of parabolic path. Here, out of three coordinates, we are considered two coordinates, that is x and y. Or when you hit the 6, that ball, cricket ball, moving parabolic path. Okay, that is an example for two-dimensional motion. Or any one object revolving in a circular path or rotating in a circular path. That is a two-dimensional motion. Example for that one, all planets revolving around the sun or electron revolving around the nucleus. All planets revolving around the sun or electron revolving around the nucleus. Okay, this is a two-dimensional motion. Okay, in this chapter, mainly we are studying about the scalar and vectors. Already I explained this one. What is the meaning of scalar and what is the definition of a vector? Scalar nothing but a physical quantity having only magnitude, no direction. Vector quantity nothing but that physical quantity having both magnitude and direction. That is called as vector. Example for scalar: length, mass, time, distance. These all comes under scalar quantity. And example for vectors: displacement, velocity, acceleration. Okay, these are comes under vector quantity. Okay, scalar and vectors, first one. Then next, representation of a vector. How to represent the vector or vector quantity? Okay, see here, scalar quantity we are denoted by only letters. Ordinary letters, but vector quantity we are represented by letters. Over on the letter we write on arrow mark, that is called as vector. And types of vectors. Types of a vector. Here so many types are there. Null vector nothing but zero vector, unit vector, positive vector, negative vector, or it is also called as parallel vector and anti-parallel vectors. There are concurrent vectors, coplanar vectors. Okay, these are the types of vectors. Next one, triangular law of vector addition. By applying Pythagoras law, triangular law of vector addition. What is the meaning of triangle? The triangle consists of two sides. Triangular law of vector addition. Addition nothing but adding. Triangular law of vector addition. This one is a very important concept in the motion in a plane. Every time in a first piece exam, okay, it this question will be asked for only 3 marks. The next one, parallelogram law of vector addition. This one also very important. Okay, this one also 3 marks question. Parallelogram law of vector addition. Out of these two, one is compulsory for your board exams, and maximum CET and NEET questions also arises from these two concepts: parallelogram law of vector addition and triangular law of vector addition. Then after that, position and displacement vector. Already explained the definition of a position and displacement. Position and displacement. Position and displacement of a vector. What is the definition of a displacement? A body changes a position from one point to another point in a particular direction. Body changes direction in a particular direction. Okay, that is called as displacement. Then after that, equality vectors. Equality vectors, and next concept, multiplication of a vector by real number. Okay, addition, subtraction, multiplication. Okay, all are we are studying in the motion in a plane. Addition and the subtraction of a vectors. And last one is the resolution of a vector. Resolution means resolving, separate the vectors. For example, 7 is divided into 2 forms, 3 plus 4, like this, 5 plus 2. It means resolution, separate the vectors. Okay, up to here, resolution of vectors are over. Okay, these are the only explanation of the syllabus. Okay, up to here, I explained the syllabus. The next one, parabolic path, projectile motion. Here in this projectile motion, we are studying about the time flight, horizontal range, and height. Okay, that the 3 equations are very important for your theory, CET, and NEET, and JEE also. Okay, this, dear students, this is a very important chapter. Listen carefully and make out your own notes. Okay, don't miss the each and every topic. The next, okay, next one concept, motion in a plane with constant acceleration. Dear students, already we know that acceleration definition. What is the definition of acceleration? Changes velocity with respect to time. Okay, velocity changes with respect to time. A is equal to V divided by T. Okay, ವೇಗೋತ್ಕರ್ಷ ಅಂತ ಕರಿತೀವಿ. ವೇಗದಲ್ಲಾಗುವ ಬದಲಾವಣೆ ಮತ್ತು ತೆಗೆದುಕೊಂಡ ಕಾಲಕ್ಕೆ ನಾವು ಏನಂತ ಕರಿತೀವಿ? ಆಕ್ಸಲರೇಷನ್, ವೇಗೋತ್ಕರ್ಷ. Motion in a plane with constant acceleration. And next one is the relative velocity in 2 dimensions. Relative velocity. Okay, relative meaning familiar. Okay, relative velocity in 2 dimensions. We are comparing the velocity for one body with respect to another body. For example, on a straight line road, one car and one bus are moving. We are comparing the velocity, one body with respect to another body. Car with respect to bus, or bus with respect to car. Okay, that is called as relative velocity. Okay, ಯಾವುದೋ ಒಂದು ರೋಡಿನ ಮೇಲ್ಗಡೆ ಬಸ್ ಮತ್ತೆ ಕಾರ್ ಹೋಗ್ತಾ ಇದೆ ಅಂತ ತಿಳ್ಕೊಳ್ಳೋಣ. ಓಕೆ, ಇಲ್ಲಿ ನಾವು ಏನು ಮಾಡ್ತಾ ಇದ್ದೀವಿ? ವೆಲಾಸಿಟಿ ಕಂಪೇರ್ ಮಾಡ್ತಾ ಇದ್ದೀವಿ. ವಿ ಆರ್ ಕಂಪೇರಿಂಗ್ ದ ವೆಲಾಸಿಟಿ, ಒನ್ ಬಾಡಿ ವಿತ್ ರೆಸ್ಪೆಕ್ಟ್ ಟು ಅನದರ್ ಬಾಡಿ. ಕಾರಿನ ವೇಗ ಎದಕ್ಕೆ ವ್ಯತ್ಯಾಸ ಮಾಡ್ತಾ ಇದ್ದೀವಿ ನಾವು? ಬಸ್ಸಿಗೆ. ಬಸ್ಸಿನ ವೇಗ ಎದಕ್ಕೆ ವ್ಯತ್ಯಾಸ ಮಾಡ್ತಾ ಇದ್ದೀವಿ ನಾವು ಇಲ್ಲಿ? ಕಾರಿಗೆ. ಓಕೆ, ದಟ್ ಓನ್ಲಿ ಕಾಲ್ಡ್ ಆಸ್ ರಿಲೇಟಿವ್ ವೆಲಾಸಿಟಿ. ಅದಕ್ಕೆ ಏನಂತ ಕರಿತೀವಿ ನಾವು? ರಿಲೇಟಿವ್ ವೆಲಾಸಿಟಿ ಅಂತ ಕರಿತೀವಿ. ದೆನ್ ಪ್ರೊಜೆಕ್ಟೈಲ್ ಮೋಷನ್. Projectile motion nothing but when we are throwing the stone in a space. Okay, due to that force, that stone move in the space, and after reaching certain height, it comes down because of a gravitational pull of the earth. ಯಾವುದೇ ಒಂದು ಸ್ಟೋನ್ ಅನ್ನು ನಾವು ಮೇಲೆ ಎಸೆದಾಗ ಈ ಡೈರೆಕ್ಷನ್ ಥ್ರೋ ಮಾಡಿದ್ರೆ ತಿಳ್ಕೊಳ್ಳಿ. Okay, it comes down in the same direction. Okay, for example, when we throw the stone in a space, that stone covers maximum height in the space. After reaching certain height, again it comes down in the direction of a applied force. See here, when you apply force in this direction, body comes down in the same direction like this, because of a gravitational pull of earth. When you throw stone in a space, it covers one path. Okay, that path you call as parabolic path. ಅದಕ್ಕೆ ಏನಂತ ಕರೀತೀವಿ ನಾವು? ಪ್ಯಾರಾಬೋಲಿಕ್ ಅಂತ ಕರೀತೀವಿ. ಈ ಒಂದು ಕರ್ವ್, this one curve we call as parabolic path. For example, when you hit the 6, okay, when you hit the 6, it reaches maximum distance in a space. Maximum distance in a space. For example, this one is considered as a bat. This one is a ball. When you hit the 6, that ball moving the space in a parabolic path and it reaches the target. It reaches the target. Okay, this one curve called as parabolic path. ಅದಕ್ಕೆ ಏನಂತ ಕರೀತೀವಿ? Parabolic path. Okay, that is called as projectile motion. ಅದಕ್ಕೆ ಏನಂತ ಕರೀತೀವಿ ನಾವು? Projectile motion. Okay, this one is a projectile motion. And next one is the maximum height of a body. Maximum height of a body. After applying force on the body, that body covers maximum height in a space from its mean position, from the earth surface. This one called as maximum height. ಯಾವಾಗ ನೀವು 6 ಅನ್ನು ಹೊಡೆದಾಗ ಆ ಒಂದು ಬಾಲ್ ಸ್ಪೇಸ್ ಅಲ್ಲಿ ಮ್ಯಾಕ್ಸಿಮಮ್ ಡಿಸ್ಟೆನ್ಸ್ ಕವರ್ ಮಾಡಿತ್ತು ಅಂತ ತಿಳ್ಕೊರಿ. ಓಕೆ, ಮ್ಯಾಕ್ಸಿಮಮ್ ಹೈಟ್ ಕವರ್ ಮಾಡಿತ್ತು ಅಂತ ತಿಳ್ಕೊರಿ. ಅದಕ್ಕೆ ಏನಂತ ಕರೀತೀವಿ? ಮ್ಯಾಕ್ಸಿಮಮ್ ಹೈಟ್ ಆಫ್ ಎ ಪ್ರೊಜೆಕ್ಟೈಲ್ ಬಾಡಿ ಅಂತ ಕರೀತೀವಿ. ಮ್ಯಾಕ್ಸಿಮಮ್ ಹೈಟ್ ಆಫ್ ಎ ಪ್ರೊಜೆಕ್ಟೈಲ್ ಬಾಡಿ. Okay, this one is called as maximum height of a projectile body. Then time of flight. Time of flight. When you hit the 6, okay, body covers this much of distance from one point to another point. It changes the position. This much of distance. Time taken the body to reach maximum height. This one is called as time of ascent. ಇಲ್ಲಿಂದ ಇಲ್ಲಿ ಮೇಲ್ಗಡೆ ಹೋಗೋದಕ್ಕೆ ಏನು ಟೈಮ್ ತಗೊಂಡು ಅದಕ್ಕೆ ಏನಂತ ಕರಿತೀವಿ? ಟೈಮ್ ಆಫ್ ಅಸೆಂಟ್ ಅಂತ ಕರಿತೀವಿ. ಆಫ್ಟರ್ ಹಿಟ್ಟಿಂಗ್ ದ 6, ದಟ್ ಬಾಲ್ ಕವರ್ಸ್ ಮ್ಯಾಕ್ಸಿಮಮ್ ಹೈಟ್. ಟೈಮ್ ಟೇಕನ್ ಟು ಕವರ್ ಮ್ಯಾಕ್ಸಿಮಮ್ ಹೈಟ್ ಫ್ರಮ್ ದಿ ಬ್ಯಾಟ್ or from the mean position, from the earth surface. This is called as time of ascent. And from that height, again it comes down after falling on the earth surface. Okay, time taken by the body to complete next off from height to earth surface. This one is called as time of descent. Time of descent. Okay, then total time flight nothing but time flight nothing but time of ascent plus time of descent. Okay, time taken by the body to complete one parabolic path, one projectile path. That one is called as time of flight. Okay, ಇಲ್ಲಿಂದ ಇಲ್ಲಿವರೆಗೆ ಬರಬೇಕಾಯಿತು ಅಂತಂದಾಗ ಆ ಒಂದು ಟೈಮ್ ಏನು ತಗೊಂತದೋ ಆ ಒಂದು ಟೈಮ್ ಪೀರಿಯಡ್ಗೆ ನಾವು ಏನಂತ ಕರೀತಾ ಇದ್ದೀವಿ? ಟೈಮ್ ಆಫ್ ಫ್ಲೈಟ್. Time taken by the body to complete one projectile. That is called as time of flight. Then last, range of projectile body. Range is nothing but distance. How much of distance it covers? Okay, that distance, range covered by a body or distance covered by a body is depend upon applied force. Applied force. When you apply smallest force, it covers smallest distance. When you apply largest force, it covers largest distance. Okay, the distance between from initial point to final point, that distance is called as range of a projectile or horizontal range of a projectile. It is also called as horizontal range of a projectile. Okay, ಮೊದಲನೇ ಸ್ಥಾನದಿಂದ ಮತ್ತು ಅಂತಿಮ ಸ್ಥಾನದವರೆಗೆ ಎರಡರ ನಡುವಿನ ಅಂತರವನ್ನು ನಾವೇನಂತ ಕರಿತೀವಿಪ್ಪ ಅಂದ್ರೆ ರೇಂಜ್ ಆಫ್ ಎ ಪ್ರೊಜೆಕ್ಟೈಲ್. That range is depend upon applied force. Then last one, uniform circular motion. Uniform circular motion. Uniform means equal. Body covers equal displacement in equal interval of time. That body rotating in a circular path with uniform motion. Okay, ಯಾವ ತರ ಮೋಷನ್ ಆಗುತ್ತೆ? ಅದು ಯೂನಿಫಾರ್ಮ್ ಸರ್ಕ್ಯುಲರ್ ಮೋಷನ್. ಸರ್ಕ್ಯುಲರ್ ಅಂತಂದ್ರೆ ಇದರಲ್ಲಿ ರೌಂಡ್. uniform circular motion. For that uniform circular motion, centripetal force is required. ಕೇಂದ್ರಾಭಿಮುಖ ಬಲ ಅಂತ ಕರೀತೀವಿ. ಕೇಂದ್ರಾಭಿಮುಖ ಬಲ ಬೇಕಾಗುತ್ತೆ. ಯಾವುದೇ ಒಂದು ವಸ್ತು ಓಕೆ ಸರ್ಕ್ಯುಲರ್ ಆಗಿ ಮೂವ್ ಆಗಬೇಕಾಗಿತ್ತು ಅಂತಂದಾಗ ಅಲ್ಲಿ ಒಂದು ಬಲ ಬೇಕಾಗುತ್ತೆ. ಆ ಒಂದು ಬಲಕ್ಕೆ ಏನಂತ ಕರಿತೀವಿ? ಕೇಂದ್ರಾಭಿಮುಖ ಬಲ. ಇಂಗ್ಲಿಷ್ ಅಲ್ಲಿ ನಾವೇನಂತ ಕರಿತೀವಿ? ಸೆಂಟ್ರಿಪಿಟಲ್ ಫೋರ್ಸ್. ಕೇಂದ್ರ ತ್ಯಾಗಿ ಬಲ ಅಂತಂದ್ರೆ ಸೆಂಟ್ರಿಫ್ಯೂಗಲ್ ಫೋರ್ಸ್. ಫಾರ್ ದಟ್ circular motion of any one body, we need one centripetal force. Centripetal force. For example, electron revolving around the nucleus. Electron nucleus na sutta suttubakagitte anta tilkori. Okay, here require one important force, that is the centripetal force. ಏನು ಬೇಕಿಲ್ಲಿ? ಸೆಂಟ್ರಿಪಿಟಲ್ ಫೋರ್ಸ್ ಬೇಕು, ಕೇಂದ್ರಾಭಿಮುಖ ಬಲ ಬೇಕು. ಫಾರ್ ಎಕ್ಸಾಂಪಲ್, ಆಲ್ ಪ್ಲಾನೆಟ್ಸ್ ರಿವಾಲ್ವಿಂಗ್ ಅರೌಂಡ್ ದ ಸನ್. Here which force is present? Centripetal force also present. That centripetal force required for rotational motion of a body or circular motion of a body. Okay, centripetal force equation Fc is equal to mv square divided by r ಅಂತ ಕರಿತೀವಿ. Fc ಅಂತಂದ್ರೆ centripetal force, m nothing but mass, v nothing but velocity ವೇಗ, okay, m ಅಂದ್ರ ರಾಶಿ and r nothing but radius ಅಂತ ಕರಿತೀವಿ. ಸೆಂಟ್ರಿಪಿಟಲ್ ಫೋರ್ಸ್. ಈ ಸೆಂಟ್ರಿಪಿಟಲ್ ಫೋರ್ಸ್ ಯಾವಾಗ ಬೇಕಾಗುತ್ತೆ? ಯಾವುದೇ ಒಂದು ವಸ್ತು ಸರ್ಕ್ಯುಲರ್ ಮೋಷನ್ ಅಲ್ಲಿ ರೊಟೇಟ್ ಆಗಬೇಕಾಗಿತ್ತು ಅಂತಂದ್ರ ಸೆಂಟ್ರಿಪಿಟಲ್ ಫೋರ್ಸ್ ಬೇಕು, ಕೇಂದ್ರಾಭಿಮುಖ ಬಲ ಬೇಕಾಗುತ್ತೆ. Okay, dear students, up to here I am explained only introduction about the motion in a plane, syllabus of the motion in a plane. Okay.